you for being here. So I guess at this point you've seen me around most of the time just to gather you and bring you somewhere. But hello, I'm Sapienza. I'm actually a senior researcher here at the ISI Foundation and recently became an assistant professor at the Center for Social Data Science at the University of Copenhagen. And today I'm going to give you an introduction to fairness and bias in machine learning. This is a topic that I recently started to explore, so I'm not expert in this, but I wanted to bring you a perspective into saying, okay, this is something everyone is talking about, but how does this affect algorithmic fairness and bias, and how does this enters in our everyday research and models. So first and foremost, I want to thank Germans. He's a PhD student in Computational Social Science at the Technical University of Denmark, and he's a teacher in algorithmic fairness, accountability, and ethics. This is a course that he does at IT University of Copenhagen, and I just want to give a lot of credits to him because he helped me put together some of these ideas and some of the code for the lecture. So, as I mentioned before, to you, this will be an introduction. So we discussed fairness, ethics, there was privacy mentioned at the beginning of the week, and what's my aim for today is to take a step back to all of that and start to think about, okay, but now that we discuss all of these, what is exactly fairness? What's equity? What's equality? What's bias? Because we talk about bias, but we never sit down and operationalize the meaning of it. And unfortunately, or fortunately, when we have to hard code things in our laptop, create models that do and prediction, and that affect our society in the way in the way it functions, we need to sit down and decide, okay, but what am I targeting? What group I decide that needs a bit more fairness? How do I find whether my data is biased? What type of bias I'm looking for? And all these questions. So if everything goes as I'm hoping, you will be left after these lectures with more questions than answers. But hopefully this will give you, a starter to say, okay, but maybe I can go and look at these papers, maybe I start looking at this issue from this angle, and hopefully it will start a discussion among us more than anything else. All right, so I don't think I have to tell you that AI and machine learning is everywhere in our society. As of today, we use AI in personal assistants, on your phone. We have AI in social media. They recommend us content that we are interested in based on, our similarity to other users in the same platform, and many, many more applications, right? We have self-driving cars, maybe in the future released in society. We have many things that help us with our home. So for instance, we can use our smartphone to decide whether to switch on or switch off our thermostat, and this would help us, getting the perfect temperature and also saving some money when we are not home. And then there's also AI and machine learning prediction in terms of healthcare and other areas in society. So I don't have to convince you on this. The problem in here is that most of these elements, most of these models are for us, as of now, black boxes that uses our data and do something. And we're not really sure what that something is, but we are constantly interact with it. So, of course, this raises a lot of questions. So if my data, my behaviors are studied, the way I connect and interact with others are used to, give me better ads and whatnot, this may be useful, of course. This allows me to get to information that is more targeted for me, and there's benefits to it. I'm not gonna say that this is all things that we have to throw out of the window. So there's progress, and that's a good thing, but at the same time, we started thinking about other questions, right? So these models are based on our data might be biased, and then there's privacy concerns. You had a lot of discussion about this on Monday, right? So what's about our data? Am I giving consent to this data to be used, and many other issues that are there. And then the question about fairness. So are these models actually influencing society in a way that's making it fairer for us to interact with, or are they increasing the bias that is already existing? Well, it turns out for algorithmic fairness, this story is not that long or far back in the past. There's actually much more attention that is given in the late years, and I've been hearing more and more, discussions about fairness and bias, especially in machine learning. Just even in this summer school, you had different lectures that touched from different angles this question. So it's nice that we're digging there, but as I said, we need to kind of operationalize what we mean by fairness and what we mean by bias. I've used the same picture as Professor Karim before, but this was for me to say there's many definitions of fairness. So this is a disclaimer. There's many ways of talking about fairness. There's many ways of talking about bias. There's no consensus on what that is, and there's no consensus about how to tackle the issue. And so when we talk about fairness, you had this before, I'm not going to go through it, but you can talk about equality, you can talk about equity, you can talk about other aspects of it. And one important point that I want to make is that there's no free lunch. So as soon as we try to optimize for whatever we decided fairness is, or whatever bias we decided we want to mitigate, we're also working against the very same model we are creating, because models in here, they optimize for a certain outcome. They are trained to learn specific patterns, and they use those informations to achieve the best accuracy and prediction power they can. So they're optimized for that, and as soon as we decide that we need to put into the picture the mitigation of bias or the enhancing of fairness, this means also for us to decrease our model performances. So we need to really be careful into understanding how we are acting on the model, and whether we are not then taking the model and just throwing it out of the window, but use it for something that's still meaningful and useful. There's also, as I said, a bit of an issue in there because fairness can be achieved in different ways. And again, sometimes how people talk about fairness, we think there's a common consensus, but actually there's not necessarily one. So let's try it out. How would you define fairness? So take a few minutes, chat between you in your group, and then we'll try to see whether there is a consensus in this class or whether different types of fairness arises just among us. So yes, just jump, go for it, do it. All right, time's up. Can we hear some of your discussions? So let's start from here.
Okay.
What did you discuss about? What's fairness?
Three of us
Yes.
talked about our project that some of us do not have the experience with Python or etc. So we contribute to the project in another way. So it's not fair to expect the same amount of Python work from each of us. It's not fair.
So fairness, if you want to summarize this,
It's not equality, but it's equity.
it's equity.
Yeah.
Okay. What about here, over here? I heard the term bias from this side. You discussed a bit about it.
Yeah, well, we were thinking about that fairness would be like equity as well for us, but like in the from the perspective of AI, it's hard. So when you don't know what's the bias, then you could not like correct for it.
Okay, so in what you're thinking is that fairness is something that is closely related to bias, and equity is the final end of what you want to achieve. We are changing name, but then we should talk about what's equity and how it's achievable as well, right? Let's take one more from the back. Here. Oh, here. Did you discuss? Yes.
You can say that taking one box from the shorter one,
Yes.
and the taller one and put it under the shorter one as in the picture. But then we asked that, is it not something like Robin Hood? So,
Redistribution of
yeah.
the resources, you
So
mean?
we say that for health and education, it will be reasonable to think about fairness, but for the other things like income and other things, we should discuss more because it will depend on other things.
Okay. So what I can conclude for this is that again, it's a really hard question. It's super high level fairness. We think we have an idea what it is and how it should act in society. But then when we have to put it in words, it's really hard to give a definition, right? Well, luckily for us, we have some definitions out there, and this is taken from a survey. And all the papers that I'm going to mention today are going to be in the GitHub repositories that I'm going to give you there, so you can go ahead and read them if you're more interested in this. But the way they, define fairness, it's taken from decision making, and I'm just going to read it out loud. They say fairness is the absence of any prejudice or favoritism toward an individual or group based on their inherent or acquired characteristics. So an unfair algorithm is one that makes decisions and whose decisions are skewed toward a particular group. So in this definition, and I'm going to touch upon this a bit later, I think at the beginning when you read it, it's quite clear, it's nice, it's written there, but then it's intrinsically connected with bias, right? If we just look at the algorithm part, this says the algorithm is skewed towards someone, so it has an inherent bias, and thus it's an unfair algorithm. I'm going to touch a bit upon this later, but this is the working definition that we have as of now. One of the most known examples of algorithmic unfairness is the one that we had from this case of Compass. So there was an investigation done from ProPublica. I think you are aware of this case. Can you give me a hand if you already know about this?
We have the presentation.
A presentation, yeah, okay, perfect. So you know more or less. I'll just give you a brief description again. So there was this model. It was the Correctional Offender Management Profiling for Alternative Sanctions. This is an algorithm that basically was predicting the likelihood of people that got incarcerated to receive for their recidivism. So basically, the likelihood that they will go out and then commit a crime again, and then judges, they were using the information from this algorithm to make decisions about, their cases. So it turns out, yes?
As far as I know, Compass is not transparent about their algorithm.
They are not transparent about their algorithm at all. There has been studies that try to replicate their performances and analysis. And there's actually a study that I'm going to show you afterwards. There's in the slides that there's no their model, but they show that basically the model from Compass is not better or more complicated than a linear model. So just putting it out there. But so this was a huge case, right? That raised awareness about machine bias and how bias in society, and especially in the data we use to map society, can lead to unfairness. The main takeaway from the ProPublica analysis that's out there, again, if you want to have a look at it, the main takeaway was that this model was found to be biased against African Americans, and basically what happened is that the model falsely predicted that they were at a higher risk to recommit crimes. The problem with this is that the underlying data that they were using were skewed towards this group. So in a way, the model was just learning from the data and was replicating this bias over and over. So the study I was mentioning is this one. They started questioning the common discussion about how machines are making our life better, and they achieve better prediction than humans, and they can help us in decision making, etc. So they asked the question: is that really true? And they took the case of Compass. And in this paper, they actually showed that their model was as good as the Compass model. So they achieved an accuracy that was it's not here, but that was comparable, and they showed that they could do that with only 2 features among the 130 plus features that the Compass model is supposed to use. And in those 2 features, there was not even race. So it was something connected to race, but it wasn't just the fact that there was the column in the data. It was the fact that there were some mechanism underlying society that were making those type of samples correlated to the race. So one key point from here that I want to highlight is that sometimes it's not as easy as we think. We think, okay, we shouldn't use race to make decision about A, B, and C. Why don't we just remove this from the picture? We just don't use that type of data. Unfortunately, the way that our gender, our race is sometimes correlated with other factors and other features. So we need to take that into account, and the simplistic, we take these and we are not considering anymore solution is not a good solution as well. Then what they've done was to try to understand whether a model was actually better in taking decisions than humans, and not only humans that were working in that specific area, lawmakers, etc. No, just random people. So they took a set of random people and they said, okay, these are the profiles of our cases, and we wanted to know whether you think these people will recommit crimes in the future. So they kind of replicated what the Compass model was doing, but just with people that weren't trained to do that. And they give them, as I said, just a couple of features, which were, I need to remember, I think one was the type of crime they committed and their age. That was it. And so what they found was that humans actually have comparable accuracy to the model that it was used to make decisions. So in a way, humans without prior training could achieve the same performance as the model that was used. And in the end, they found also that there were the same biases underlying it. And in here, again, they were given the initial race of the defendant. They were completely unaware of this. And what they found again is the problem with Compass, that basically you have a higher false positive rate for black defendants, and then you have a higher false negative rate for white defendants. So basically it was just predicting them to be at a higher risk. And one thing that I took away from this paper is actually this little sentence, and the fact that we should ask ourselves whether we would put these decisions in the hands of random people who respond to online surveys, you know? Because this is exactly what they've done. They took random people out there that answered their surveys with no prior knowledge of anything, and they found the same thing. So I think we should treat our models in the same way, with a generous amount of criticism, and try to open what we usually call the black box to try to understand what's going on under the hood. All right, so Compass, as you know, it failed, and it failed due to biases. But here is the next question: what is bias, right? And then again, there's different definition. There is some concepts that are vague. There's different definition depending on the field you are talking about. So, for instance, when we talk about bias in statistics, it's something that it relates to the fact that if you have a population and you want to estimate some measure on the population, you often don't have access to everyone, so you get a sample from the population, and there's a bias in statistics if your estimate in that subsample is not, it's different from your expectation from the population. And this is the statistical one. But if you go to sociology instead, that's defined as a tendency to prefer a thing over another that prevents objectivity. So it's a bit broader, but it goes maybe more into the direction of what we think about when we have the concept of bias in mind. And so that objectivity that is missing is basically influencing our understanding of some mechanisms and some outcomes, right? So here there's some example. For instance, there's a bias towards respecting male teachers more than female teachers, and this can be connected to some stereotypes, some cultural bases, and so on and so forth. But what about machine learning? Is there a definition of bias in machine learning and AI? Well, actually, there's no specific definition, but in general, this term is used to indicate anything that is leading to some prediction issues or some possible unfairness. So when our prediction, as we've seen for the case of Compass, is doing something that is, enhancing the benefits of some subgroups and not for others, for instance. All right, and now I want to go back to the actual definition of fairness that we had before, and to this connection between fairness and bias. It seems that they are really related. There's one and there's the other. There's some connection among the two. One can imply the second. But a question that I have for you is, do you think bias necessarily imply unfairness? So anytime there's any type of bias, that means that we will have some unfair prediction, unfair behavior, unfair yada yada yada. Take some minutes and discuss whether this is yes or no and why. I don't know how All right, let's hear some answers. What about over there? Your group? All right, let's hear. That's a hot topic, I know. Okay, what did you come up with? Is that bias necessarily implied unfairness?
We say no.
Okay, how come?
Because there might be some minorities that you want to treat a bit differently. Like maybe if you were in some kind of hiring process, you want to make sure that there is a certain number of people that represent minority groups, and that's a bias, but it's not an unfair bias.
All right, let's hear. Did anyone come up with something different? Let's hear from there.
Okay. We thought that, but we are not sure at all.
It's okay.
We thought that probably machine learning models are based in Sapienza on some bias. Because if you have to make a prediction based on some features, and it is unfair when you have to make a prediction on some features that bring to unfairness. But for example, in a sport, in a context of sport, you have to select the people that are very good in physical aspect, in height, that are thin, etc. And in that context, this is not unfair, but in a certain sense there is a bias. While in a CD selection, if you select CDs from if you exclude women that are pregnant, is not fair. But if you select if you exclude people that do not have a car license, probably this can be a good reason to exclude that person for a certain kind of work, of job.
All right, so in a way, what you are both saying is that we usually think about bias as a bad thing, right? But at the end of the day, it can be useful. It really depends on the context and how it's used and what features it's related to, right? And yeah, I mean that's the deal there. There's bias does not necessarily imply unfairness, right? If we think about gender discrimination in the workplace, and so just deciding that certain genders will be better off or not in certain contexts, that's something we don't want to achieve. That's unfair. However, if we take into account gender in other contexts, so to get, for instance, specific medical diagnosis, then the same feature the same type of bias become actually more fair, because we know that the physiology of the biology of women and of females and men, they can be different. The way the type of problems, healthcare problems that they get are maybe different. So having something that is specialized towards that is actually makes the outcome fairer. Or exactly with the examples they were mentioning, or the examples they were mentioning, I think you can find many different cases. So now that we know that bias can be good or bad, it depends on the context, let's talk about where it comes from, right? And it turns out that bias is present everywhere and at all stages of the AI life cycle. So it's not just based on the data. For sure, there's data bias. So data can carry out some biases depending on the measures we take, depending on whether they reflect some stereotypes in our society depending on many different aspects, and that's there. There's also like bias in the model. It depends, especially when we don't really know how it is working under the hood. We have to be really careful and try to understand what's the uncertainty of the predictions that we are doing. There's bias in the training part, in the evaluation part, in the interpretation as well, right? Because we're humans, we carry our own biases when we look at the results we get. And we extrapolate information also based on our, on our backgrounds and, our upbringings. So it's in all stages of the AI cycle, but there's also many different types of biases. And this is one of the problem and issues that I faced, because there's also many different ways in which people that study the issue categorize biases and give definitions of biases. And most of the time, they are not necessarily well separated. I guess that's the problem with any type of clustering we try to make. They are also interconnected with each other. There's one type of reasoning about categorization of bias that I found really useful, which is to think about more than the types, but to think about where it comes in the terms of the process and how it can influence and create a feedback loop that actually increment the biases and problems and predictions that we have. So for instance, because bias can come up at different stages, they also can influence the next step. So there's bias from data to the algorithm. So the idea that the data is biased in some way. It could be because we are aggregating, so we can have issues related to, for instance, the Simpson's paradox. I don't know if you are aware of it, but basically the idea is that when we aggregate, we are maybe losing the actual the actual reality of how different measurements could be in subgroups, because we aggregate and we might have trends that are completely on the opposite side than what we would have had if we disaggregated different subgroups. There's also a problem with longitudinal data, like for instance, many of the studies that we have as of now, they don't track people for years and years and years, because that's really hard to achieve. So most of the time they do cross-sectional experiments where different cohorts of people are taken for a before and after and to see the evolution, but that sometimes create bias because the cohorts are not comparable or not exactly the same, or they're biased in some way. And this is fitted into an algorithm, right? So this kind of influences the way the algorithm learns and learns to disentangle different patterns, and it learns the same very patterns and biases that are present in the data. So this is one part of the cycle. But then algorithms are not just out there in the void. They are used in society for something. So before you were being presented with ranking biases. So, for instance, when you do a search on Google, you don't often scroll all existing pages that are out there, but Google decides that there's some importance in some specific information, and it will put that at first. So the information that you are getting out is biased in the sense that it's taken out from the algorithm that kind of prioritize certain context instead of other. So the algorithm is not just there, but it's also influencing what we get out. And this is a feedback loop, because at that point, we as users interact with the algorithm, and then we create even more bias in that sense. So for instance, we can have different representations in different platforms, or even in the way we talk, different subgroups, depending maybe on age. We use the same language, but maybe we use it in a different way, and that could even lead to misunderstanding between people. There was a case of use of emojis. So emojis for some subgroups were used in a specific way, but that was counterintuitive for other people, and that really led to miscomprehension when it came to discussion into these platforms. So as you're seeing, this is not only something that it's there and it's happening and then we can just mitigate by taking out a feature or whatnot, but it's something that it's also influencing what we do and the process we do because of this high integration of AI and machine learning in our society. In here, there's also, this paper was really interesting because they tried to categorize different biases in social data, and they categorized them with by taking into account different data properties. So they categorized them in these 5 groups, and was population bias. Some of these we've seen before, content production bias, etc. I'm gonna just keep over. In here you have all the definition, but I put them there because then afterwards you can take the slides and you can hack them, and it might help you during the exercise to look at the different biases there are out there and how they are defined to decide what type of bias is in the data you're going to look at. So I'm just going to skip through this and go to the final question, which is how can we handle bias? And so I guess as of now you might know the answer, which is there's no unique answer to this. So we've seen before in network properties, we could treat the network in a certain way, and we can account for biases in certain ways. In machine learning, that's a bit different, and everyone does actually different actions to account for it. Let's see what some of the smarter tech that we have out there actually came up with. So I don't know if you are aware of this, but Google Photos in 2015 started to auto-label images that were uploaded on their site, and this created a huge backlash because there was some bias in their labeling. So unfortunately, the bias was that people with dark skin colors were labeled as gorillas. And what do you think they've done to resolve this issue? Does anyone know? Well, they decided to fix this by removing the gorillas from their training set. Smarter people on planet here, yes. But they're not alone. We have also the case of IBM facial recognition. In 2018, basically they started selling a software that detects faces and can gather emotional reactions. And you're saying, yeah, okay, nice. But there was some bias found, and basically it was working really well. Their performance were great, but when disentangled based, on different types of users here by gender and color of the skin, they found that there was a huge bias in the way this software would work, and basically it had a really bad performance in comparison to the other group for darker females. So how did they solve this issue? Does any of you know? Well, at the beginning they decided to enhance their training set. They said, okay, we have a minority class, and we put a bit more effort into having a more balanced data set, and that could help in our facial recognition software. But then it took them a couple of years to decide that they didn't want to spend any more money on improving this software, and then they decided to not sell it anymore. And finally, we have another beautiful example, Google Translate. In 2018, this was found. So Google Translate, I guess everyone used it, at least one. It used machine learning to translate one language to another. And the thing is that the machine learning algorithm, it also learned some of the systemic biases and stereotypes that are in our language. So in here, I'm sorry, it's really hard to read, but basically when talking about doctor, it would translate it in a language that is actually gender. It would translate it to a male characteristic from a language that is not gender. And then when it comes to, instead of a nurse, that would be a female instead. So it learned these, stereotypical professional positions from the text it was used to train it. And they also decided to fix this, and this fix is still there, so you can try it out. And they fixed it in this way. So they hard-coded this problem in their algorithm, and they decided, okay, this is what happens anytime we are uncertain on whether we should translate it in a female or male sentence, or in what type of gender. Whenever there's uncertainty, what we do is that we just provide both of them, which seems nice. Unfortunately, they've done it only for the most used languages. So I tried it the other day with Italian, and the nurse thing still came out. All right, so this was just to say, again, there's no final answer, there's no standard approach, and there cannot be, because these different algorithms do different things. They learn from different data, so we cannot just create one solution for society and we're done. We have to take each case and do our best to dig into the data, to dig into our model, and try to understand where bias come from and whether this can lead to unfairness or not. This can be done at different stages in your pipeline. So as I said, bias comes in at different stages, and we can also fix it at different stages. This can be at the level of data collection and data storage. So lately there's been some proposal in doing something that's called model cards. So basically there's a spreadsheet with some questions that make you understand what is it that you're trying to achieve, what type of data you want to collect, for what purposes, and try to write down what the ethical consideration about these data are and what might be the possible problems down the line. And then this would create some, awareness of how this model works and what the data feed to them is. Then, of course, you can hard code it into your model. So this was, for instance, the example for Google. They went back and they decided to change the model accordingly. Or you can do it at the post-processing level. So basically, you have everything. You have the data. This is imperfect. It's not perfect. It's okay. You cannot do anything about it. Then we have this model. Okay, we know it creates some issues, but we identify these issues afterwards. And once we know how it acts, we kind of reverse some of the prediction in a way that we can achieve a bit more fairness. And here again, I want to say what I said at the beginning. There's no free lunch, so anytime we act at this level, we might lose accuracy, we might lose performance of the model, and it's always a matter of trade-off. So how much can we achieve fairness, and how much can we still keep a model that is functional for the purpose we want. Now, I have no time to go through all the possible ways people have actually tackled these issues. There's a lot of work that has been done for classification, and then lately there has been papers also about regression, PCA, and other types of models. Here again, you can have a look at them from the survey. I will give you the paper in the resources. And plus, there's not only the fact that there's different way of, fixing the models, but also there's different ways to achieve fairness. So what we were saying before is that fairness is like an overarching concept, and we think we understand what it is, but then at the end of the day, when we have to operationalize, we have to decide what type of fairness we want to achieve. These are some of them. Today I want to show you one of the simplest ones, which is demographic parity. And why I'm going to show this to you, because I'm going to make you implement this in the exercise later. But don't be scared, it's super simple. So I came up with this amazing example. So we have a wizard in school, and we need to admit some people because, we want to create great wizards, and we have people that may, that apply for this school, and we have a model that decides based on their knowledge of spells whether they will be admitted or not. So now our model makes his prediction, and we discover that actually there's a bias. So it's actually, this model is perfect for people that read Harry Potter books, but it's not perfect for people that didn't. So I would be completely not taking this. But so the idea is that we now found that there's a bias into groups, and what we find is that our model is perfect for the first group, right? I mean, there's a bit of an error there, but it's taking, so the darker colors are the people that indeed will manage to become great wizards after this school, right? So it's perfect for them, but it's not perfect at all for the other group. So what demographic parity wants to, so this is the idea. So how do we know this? By counting. And so we say, okay, in general, in our school, we have this probability of accept people, and this probability is almost 40%, right? So this depends on how many people we actually got over all people that applied for the school. But then when we divide into subgroups, what we find is that the probability of acceptance is actually imbalanced in between the groups. So we have that the purples are much more accepted. They have a 45% chance to be accepted, while the yellow are not. They have only a 29% chance to be accepted. So demographic parity, what it does is that it says, well, we can fix this. We have this model, this is the problem, but what we want to achieve is for these two groups to have the same probability of acceptance. Now the problem is in the way this is done, which is a bit simplistic, but nevertheless. So the idea is that there's two options here. Either we admit less purple people, so the people that read the books, or we admit more yellow people, right? So the people that didn't read the books. And the way we do that is that we select at random a number, and we say, okay, if our probability to flip the decision is so we have a threshold, so we create this threshold that is based on the ratio of probability of setting one or the other. And then when we get this threshold, what we say is that, okay, if we have, now we take a number at random, and we say if this number is lower or bigger than the two thresholds, I admit a person or not. So I change the prediction of the model from a 1 to a 0, or vice versa, from a 0 to a 1. And of course, there's many issues in this, right? Because if it was just to win a lottery or to give out more free tickets, whatever, maybe that would be okay. But in this case, there's an underlying issue which we'll discuss a bit more in the exercise session. So now, what I want you to do is to go over this GitHub page where you will find an IPython notebook. And again, the IPython notebook has only some descriptions, so if you don't use IPython, if you don't use notebooks, if you don't use if you don't use Python at all, you can still do it in R or whatever is your language of preference, because it's just questions and it's a matter of importing a CSV file. And what we are going to do in this lecture, I will just put it out here, is that we are going to partially replicate the analysis that ProPublica did. And we are going to try to dig into their data and to see where the bias was and how much it was present in the predictions they were doing. So we will have a data set, which is in this CSV file, and it has different columns, age, sex, the race. We also have, the prediction, and then we have other different type of features. They're all described there. And what we're going to do is that we're just going to read this data, clean it a bit, and then we are going to explore the data and try to understand what are the biases in there, and try to understand how can we mitigate this bias through this demographic parity method. And then at the very end, we will discuss why this could be a problematic method or not. All right, do you have the page? Yes. So how it's going to work is that I leave you working, and then I just walk around and discuss with you and help you figure out how to do it if you have questions. Cool. Thank you so much.